My name is Michela Milano, and today I'm the moderator of this panel on AI for computational sustainability and human well-being. Basically, this is a field, computational sustainability and human well-being, that is very interdisciplinary. It covers basically the computational techniques that try to solve computational global challenges for balancing environmental, economic, and societal needs for sustainable development and human well-being. Of course, we all know that artificial intelligence is a cornerstone technique that can be really help and be applied for solving these sustainability problems. In fact, there are a number of techniques in artificial intelligence that consider like machine learning and deep learning, optimization and decision support, machine vision, agent-based simulation, planning, game theory, that can really help in solving these problems. However, in these fields, we have also very important ethical and legal issues that can be taken into account and should be taken into account. And of course, all the strategies, I of course know the European one, are very concerned with the use of AI in this field. For example, Europe is launching the Green Deal that is really concerned with using also AI techniques for solving climate change problems, energy management problem, water management problem, disaster management problems. So all the problems that are related with computational sustainability, in fact. There are a number of open questions that we have proposed to our panelists. And basically, they are 3 questions, and they can also cover other questions in case. So we consider that, first of all, the scale and the complexity of problems related with computational sustainability are extremely challenges. So these problems are huge problems with a very large scale. They are subject to uncertainty. They have dynamic aspects that should be taken into account. And in this case, of course, exact algorithm that guarantees some quality of the solution can be substituted by heuristics that can deal with the scale and complexity of these problems. But of course, we don't know if we have to be concerned more with quality guarantees for the computed solution or with, efficient algorithm that can scale up. And also, what standard of experiments and case study would be desirable. The second question that we have posed to our panelists is how could we strengthen the incentives to trust the use of computational sustainability solution? Trust is a central concept, for example, also in the European strategy on artificial intelligence that wants to develop trustworthy AI systems. So systems that can be trusted by decision makers to whom we suggest solutions, and we suggest plans, we suggest decision-making processes, and in fact, the trust is really important for them to accept the suggestions from these systems. So there is also an important topic on how to create ready-to-use implementation and tools that can be applied with a small development effort in different applications. And third, there is a question on education, which is crucial for creating new skills and new talents that can deal with this problem. So the question is, what courses can be ideally taught to students, university students, but I think also school students, that can make them well prepared for working in this interdisciplinary field. So which are the main skills that they need to have? And of course, this is a very important topic for the growth of the next generation of researchers. For these panels, we have three top scientists, and that are also colleagues and good friends. The first is Professor Carla Gomes from Cornell University. Carla, I have to say, is the founder of the computational sustainability field. She received an NSF, she is a director of the Computational Sustainability Institute at Cornell University, and she received won an NSF expedition on computational sustainability and a second one for creating an ecosystem and a network. Then we have Professor Barry O'Sullivan. Professor Barry O'Sullivan from University College Cork is also director of an Insight Center in Cork. And Barry is the past president of the European Association of Artificial Intelligence. Basically, Barry has worked a lot in the field of constraint programming, optimization, its relation with machine learning, and also Barry is also working in this computational sustainability field. Pascal Van Enterijk is a professor at Georgia Tech. Pascal has worked in many top universities in the US, like UConn, Brown University, and he was also directing a research center in NICTA in Australia. Pascal has worked a lot on, it was one of the founders of the constraint programming field and constraint satisfaction and optimization field. We had the intersection with artificial intelligence and operations research. And Pascal has worked a lot on a number of very important fields in computational sustainability, like disaster management, power plants, and energy management, always at the intersection of decision support, machine learning, simulation, and optimization. So we have really the parterre de roi, so three great colleagues, three top scientists. So I'm really would like to thank them all. For two of them, Carla and Pascal, it's 5 o'clock in the morning. So I know that it's quite tough to make a talk at 5 o'clock in the morning. So I thank you, thank Carla and Pascal also for this. So I will now leave the floor to the panelists. They will have a 10 minutes presentation, and then we can open the discussion by considering your questions. And if you want to start interacting with the panelists, then it's your time to post questions and comments, okay? So for what concerns the first talk of Carla, I will share a link to a video that she has sent me. It's a 10-minute video. Carla is anyway online, so she will answer after her video, your comments. So we will do the three presentations in a row, and then we will accept your questions. Okay. So this is the video of Carla.
Hello. I'm Carla Gomes from Cornell University. It's a great pleasure for me to participate in this panel. Thank you, Michela, for organizing it and for the invitation. At Cornell, we have a variety of projects concerning three main sustainability themes: conservation and biodiversity, balancing environmental and socio-economic needs, and accelerating discovery of materials for renewable energy. In this short presentation, I'll talk about planning hydropower dam placement in the Amazon basin, the real Amazon, to address some of the questions raised by Michela concerning optimization algorithms and informing policymakers. In the last 50 years, there has been a proliferation of hydropower dams in the Amazon basin, the real Amazon. In fact, already around 200 dams have been built or are under construction, and more than 300 dams are planned or proposed. The main reason for constructing a hydropower dam is obviously the production of energy. However, when evaluating alternative placement of dams, we have also to consider the different ecosystem service that river networks provide. In fact, dams fragment rivers and therefore they affect negatively a variety of ecosystem service provided by river networks, such as fish production, transportation and navigation, and sediment production. Dams can even lead to the production of greenhouse gases due to the fact that they can flood large areas of land, which can lead to the decomposition of organic matter with the release of methane. So, from a computational perspective, we are interested in developing more ethical AI decision support systems that consider multi-objectives aligned with human values, and therefore this is a multi-objective optimization problem, and we are interested in computing the Pareto frontier. The Pareto frontier captures the trade-offs with respect to the different objectives of the different solutions of dam portfolios. Here is a simple example of a Pareto frontier. In this plot, the x-axis represents energy and the y-axis represents ecological value. If we don't build any dams, we keep all the ecological value. On the other hand, if we build lots of dams, we destroy all the ecological value. This solution is in between, and in fact, this solution has the same energy output, but a much higher ecological value than this other solution. So, this solution is dominated by the one on the Pareto frontier. On the left-hand side, we see two dam configurations with similar hydropower yields, but different degrees of river connectivity. The right configuration is better from the point of view of river connectivity, since it builds the dams away from the mouth of the river. So the river is not as fragmented as the configuration on the left-hand side. In our work, we are developing algorithms for computing the Pareto frontier, both the exact Pareto frontier, but also efficient approximations, and in particular, we are developing fully polynomial time approximation schemes for computing the Pareto frontier. We actually have a dynamic programming-based algorithm that uses a very fast algorithm for eliminating dominated solutions that runs in order n log n. To give you an example, we can approximate the Pareto frontier with 99.9% guarantee for 3 criteria in a question of minutes. We are also exploiting hybrid strategies because this problem is truly exponentially in the number of criteria. Therefore, it is important to find fast solutions of computing the Pareto frontier. In this slide, I illustrate the cost of inefficient planning and the types of message to policymakers. This curve represents the Pareto frontier considering all the dams as if we had planned them before building a single one. This is the point where we are at given the dams that have already been built. We can see the foregone environment benefits. For this amount of energy, we could have a much higher ecological value in terms of river connectivity. Alternatively, for this river connectivity, we could produce much more energy. This is the Pareto frontier going forward. We are considering many other criteria in addition to energy and river connectivity. Also, I should highlight that we have a large number of collaborators, including biologists, ecologists, hydrologists, and social scientists. Here we show the Pareto frontier with respect to energy and greenhouse gases. Not because we want to minimize greenhouse gas emissions on the left axis, the Pareto frontier has a different shape. The lower, the better. This work appeared recently in Nature Communications. The lead author is our postdoc, Rafael D'Almeida. You see his picture here. We consider two different time horizons. On the left, a 20-year time horizon, and on the right, a 100-year time horizon. A key point with this work is that if we don't plan the dams properly, we can actually end up with solutions that are dirtier than coal. You see these purple lines. And this happens because, as I mentioned before, dams can lead to the generation of greenhouse gases, since they can flood very large areas that lead to the decomposition of organic matter, resulting in the release of methane. This slide shows on the left panel the 2D Pareto frontier with respect to different criteria: river connectivity, sediment production, biodiversity, fish biodiversity, greenhouse gas emissions, and degree of regulation. We see that we lost the most ecological value in terms of river connectivity and biodiversity. In other words, the gap between the ideal Pareto frontier and the current Pareto frontier is the largest for connectivity and fish biodiversity. On the right panel, you see the 6D Pareto frontier using a parallel plot for the 6 criteria, including energy. This is a very static representation, though. So we are also developing an interactive tool for exploring and navigating the Pareto frontier for policymakers. I do think it is important to make our algorithms and approaches accessible to a broader audience and policymakers. In particular, understanding and interpreting the Pareto frontier is actually a challenge in itself. This tool allows for what-if scenarios, for example, by constraining the values for the different criteria within desired ranges, which is useful for policymakers. Let me wrap up. I talked mainly about one project, but we have many more, and the cool thing is that we identify cross-cutting computational themes across projects, here captured by subway lines. The different projects correspond to stations, and the lines correspond to computational themes. For example, we have other projects involving multi-objective optimization and spatial temporal prediction and modeling, which were also important for predicting the different criteria considered. I'm happy to elaborate more about the subway lines during the Q&A. Thank you.
Okay, thank you, Carla, for this very interesting presentation. So now we'll try to give the floor to Barry O'Sullivan.
Thank you, Michela. Hopefully you can hear me okay. And I can get my slides to behave themselves. Okay, here we go. Great, so good morning, everybody. My name is Barry O'Sullivan from the Insight Center for Data Analytics at UCC. It's a real pleasure to be here. So I just want to give, I suppose, an overview of the field of computational sustainability and look at some ways in which AI is having some significant impact, and also looking at the impacts on human well-being. And I do this because I want to highlight some important answers to the questions that Michela asked us at the beginning. So I suppose the first thing to bear in mind is that computational sustainability is a highly multidisciplinary field. And so, as you'll have heard from Carla's presentation, these are not just problems that computer scientists solve on their own, but they need domain experts, and they need a different way of thinking about how to formulate and frame these problems and what good solutions look like. So I suppose the field began in a sense, I would argue, when Apollo 8 took this very famous photograph of Earth rising in 1969, an image that we sort of take for granted now. But that was the first time that we actually saw the Earth floating in space on its own, so looking very vulnerable. And of course, that gave rise to the field of sustainable development. This is a very famous book, and Gro Harlem Brundtland, it's often called a Brundtland report. And she characterized sustainable development as development that meets the needs of the present while not compromising the needs of future generations. And we know this today, in a sense, as the 17 Sustainable Development Goals. So, you know, over that 40 years from Apollo 8 taking that photograph of Earth rising, we now have a set of 17 goals that, I suppose, set out the greatest challenges that we face in the world. Now, at an AI conference, you might wonder, well, what have the Sustainable Development Goals got to do with me, and what can I do to help advance them? Well, I would encourage you to take a look at the UN Global Pulse website, which is an entity within the Office of the UN Secretary General, and they gather together some very interesting projects on how data science, big data, AI can be used to address some of the sustainability challenges. And so just to give you some examples, this is a chart taken from one of their reports from a couple of years ago, and it gives one simple example for every one of the Sustainable Development Goals in terms of how data and in some cases AI can be used to achieve those goals. So for example, if one is looking at education, you know, looking at analyzing reasons for dropouts, if one is looking at affordable clean energy, looking at smart metering and how that impacts supply in peak periods, what kind of policies we can put in place to make sure that people are using energy properly. If you look at Sustainable Development Goal 3, which is good health and well-being, we can look at the movement of individuals and use that to predict the spread of infectious diseases. As we all know, we've unfortunately been doing that for the last year with COVID-19. And so, you know, if you look at the Sustainable Development Goals and look at the kinds of things that are going on in AI, so for example, there's a huge amount of work going on in the ethics of AI. So in terms of teaching our next generation of AI scientists, they need to have an education in ethics. They need to understand the impacts of their work. In terms of good health and well-being, there's huge amounts of work going on in terms of medical imaging, diagnostics. Here's an example of something that's going on in a surgery, which combining, you know, for example, knowledge graphs and video to help clinicians. Gender equality is obviously one of major importance, and there's lots of very interesting science going on in terms of understanding the impact and the causes of gender inequality rather. And so this is I just give an example here of some fantastic work by Joanna Bryson and some of her colleagues that was published in Science a few years ago, where they showed that that certain types of gender bias are baked into natural language, and of course, you know, that presents a very specific and unique challenge in terms of how we might deal with it. Obviously, lots of work going on in smart metering, affordable energy, lots of work on sustainable communities and smart cities. Lots of work on robotics and drones for, you know, for agriculture, these types of topics. And of course, you know, if we look no further than COVID-19, we can see lots of fantastic examples where AI is dealing with very challenging sustainability issues and very challenging health and welfare issues. So the World Economic Forum have done a variety of things over the last years, reporting on the use of AI in COVID-19. We've seen lots of interesting papers. So we've seen, this is just an example of the kind of thing that's going on. So people in the deep learning community doing building diagnostic tools for COVID-19 with, you know, incredibly high accuracy. Of course, in some sense, the pandemic itself was predicted through data before we saw lots of the sort of medical data that was that we now know. So Blue Dot was a startup company that was anticipating the outbreak, which is an amazing story. There are lots of very interesting startups that have built up around COVID-19 using AI. So this is a conversational recommender system that helps people get access to health data and information about COVID-19. It's a French startup, very interesting story. C19 Index is a is a system that basically so it scores patients in terms of their risk, so that when one is, for example, prioritizing or treating them in hospitals, one can do that get that additional information that can help clinicians direct their efforts. Of course, we've seen lots of examples of large corpuses of data being put together so people can look for treatment plans. We've seen AWS doing this. We've seen the Allen Institute for AI in Seattle doing this. This is a very interesting paper I believe is still under review, but you can find a copy of this online. So using essentially cough recordings to diagnose COVID-19 with very, very high accuracy. I suppose one of the things in terms of more broadly, and I mentioned this at the beginning, this idea of using ethics, we need to be very careful about ensuring that our technology and our science is accessible to a wide variety of people. This is a piece of work that was published by Facebook a few years ago, where they looked at does object recognition do object recognition technologies have similar accuracy in different parts of the world? And they basically took existing data sets which are geotagged, and they separated those from low-income areas from higher-income areas, and they found that object recognition, while in general very accurate, in areas of high poverty, the accuracy really decreases. And this shows a sort of an inherent bias in what we're doing that we need to be aware of it. And it's not that we set out to achieve this kind of inequity, but it's something that we need to be aware of. We need to deal with it. Obviously, lots of people are interested and concerned about facial recognition technology, especially in the absence of explicit consent. As a field, we're very concerned about the weaponization of AI technologies, and there are all sorts of diplomatic efforts that are going on at the moment in terms of codes of conduct for limiting and restricting the use of AI technology in weapon systems. And of course, people talk about the impacts of AI on our privacy and our autonomy, which is very, very important. And of course, then, coming back to energy issues, we hear lots of concerns about the energy costs of building large machine learning tool chains. This is a paper that appeared, I think, last year, maybe the year before. 2019. The date's in the bottom there. Looking at the carbon required to build some of these large tool chains. And of course, we need to deal with these sorts of things. And there's lots of ways in which we can deal with them once we're aware of them. So there are lots of issues in the field. The European Commission put together a high-level expert group a few years ago, which I had the pleasure of vice-chairing with Michela, former president of Nokia Mobile Phones. And I suppose the reason I put this photograph up is because it highlights the multidisciplinary expertise required to address these types of concerns. So here are people who are experts in AI, but also experts in ethics, people from civil society organizations, people from industry. So this isn't something that we as AI scientists can solve on our own in the traditional way that we do AI, but we need to bring in those other fields. There are lots of ethics guidelines, and I suppose this is the high-level set from the European Commission that we developed for them. But number 6 on the key requirement list is societal and environmental well-being. And of course, we have to ensure that what we're doing protects societal well-being, so protects not only our health and wellness, but also protects our autonomy, our privacy, these other issues. I'll skip over this slide just in the interest of time. But I suppose the key message is that in terms of education, in terms of how we engage together and how we educate our young people, we need to think about AI, sustainability, well-being in a multidisciplinary context. And I think if we bring together those types of multidisciplinary teams, I think we're able to do fantastic research, as Carla very beautifully exemplified in her contribution. That she has a set of projects which I'm sure we're going to talk about later on, which bring together experts from a wide variety of different fields, and this is what we need to do. And we need to get our new students and our postdocs and our PhD students not only thinking in a multidisciplinary way, but thinking but being open to the importance and the contribution that other fields can make. And I think if we can get that right, I think we can do a lot in the field of AI, computational sustainability, and well-being. So thanks, Michela, for the invitation, and I'll hand back to you now. Thanks.
Thank you very much, Barry, for your presentation. So now the third panelist is Pascal Van Enterik. Okay, we can perfectly see your screen. Pascal, the floor is yours.
Thank you, Michela. Thank you for the invitation. I love giving talks at 5 a.m., as you can imagine. So I'm going to talk about two projects that we are pursuing right now, which are in sustainable mobility and sustainable energy system. And I'll try to answer the questions that Michela has asked. I won't talk about education because Barry just did an amazing job. So I'm just focusing on the first two questions that Michela has asked. So I'm going to start with energy. So this is a project that we have with the Mid-Continent Independent System Operator. So this is a transmission operator that decides which generator are supplying power to which customers. And MISO has a slice of North America going from Canada to Louisiana. And they have about 80,000 miles of transmission lines. The generation capacity is about 200 gigabytes. So it's a massive system, one of the biggest in the United States. And what you can see at the bottom of this slide on the right is essentially the generation mix. So they still have about 30% of coal. They have about 17% of renewable, and they are one of the most innovative ISOs in terms of trying to push renewables in their system, wind and solar energy. One of the things that they are trying to do is to increase that share of renewable. In 10 years, they want to be moving from 17% renewable to about 32% and decreasing coal, accordingly. And obviously, that's a significant challenge in how you manage these systems. And so one of the problems that they have to solve is what is called unit commitment. And in unit commitment, you're trying to find out which generators is actually delivering energy for the customers, whether it's a coal generator, a gas-fired generator, wind or solar, hydropower, and so on. And so this is directly addressing one of the questions that Michela is asking, because these are market clearing algorithms. So the generator is going to put bits, and although these problems have hundreds of thousands of variables, they need to have essentially an optimal solution because that guarantees fairness. Otherwise, the generators can come and say, hey, I'm cheaper than the other guys, and therefore I should be dispatched. So it's very important for them to be as close as possible to optimality within the time frame that they are given. So this is one of the interesting things here. So optimality is not a luxury. It's essentially a requirement of the market. For instance, for them, even stochastic optimization is extremely hard because people could argue, hey, you did that in an expected case, but in the particular scenario that actually happened, I should have been dispatched. So there is a lot of resistance, for instance, in using stochastic optimization, although with the uncertainty on wind and solar, this is something that should ideally be done. So you're going to say, hey, where can AI help? I think machine learning and optimization together have a lot of opportunities in this particular area. First, because we have a massive amount of data. They solve problems every day and every couple of minutes these days for the economic dispatch or the optimal power flow. So you can actually learn a lot of things about these operations. And so these are some recent results that we have got here by combining in a tight fashion optimization and machine learning. It has to be well integrated because this system, as you may expect, has both physical and engineering constraints. You cannot, ship too much electricity on a particular line. Otherwise, you're going to break the line. You're going to switch the protection and so on. So you have very difficult physical and engineering constraint that you have to satisfy. So think about this as an empirical learning problem, but under very severe constraints. You can see how well we can actually predict what the generator should do. You can also see that when you combine machine learning and optimization, you get about 2 or 3 orders of magnitude improvement in efficiency. So that's the first applications that I wanted to talk about, and that address the fact that sometimes optimality is really important. Let me talk about the second applications where I can talk about trust. So this is based on the work we are doing in the socially aware mobility lab. And what we are trying to do here is actually address the issues in transportation in the United States. So in the United States, car ownership is still the best predictor of social mobility, upward social mobility. If you don't have a car, it's much more difficult to get a job. It's more difficult to actually access healthcare, high quality food, good schools, and so on. And mobility is very hard in the United States because you have a couple of problems. The first one is congestion. I live in one of the most congested cities in the world. This is like 24/7. You have this massive jam. And TNCs like Uber and Lyft has actually contributed to increasing congestion. There were studies in San Francisco showing that they have, in a sense, increased congestion by about 30%. And cities like New York City are restricting the number of TNCs inside the city at different times of the day. Then you say, well, don't you use public transit? This is a picture that I like from one of my colleagues where you see the space that a bus takes compared to cars. And it's a very much better use of the infrastructure in a sense, and the infrastructure is finite. But transit as a first and the last mile problem. If you make people walk about a quarter of a mile, you lose 90% of your ridership. So you really have to pick up people where they live or very close to where they live. And that's what we are trying to build. We are building this new transit system that are combining a fixed service like rail and rapid bus transit with these on-demand shuttles that can serve the first and the last mile. And so those systems are door-to-door. They solve the first and the last mile problem, but they are also multimodal, and therefore they address congestion and economy of scale. You can electrify them entirely because you manage the fleet, and therefore you have no range anxiety. And it's a sustainable model, as I'll show you in a moment. And the impact is that we can change essentially accessibility to entire population segments. So once again, I'm going to show you what we are doing in Atlanta. The current system currently is about as rail lines, and then is about 500 buses. And the transit time is about 40 minutes. And so this is the new system that we have been designing. There are very few rapid buses, about 26. But there is a very large number of shuttle, about 1,000. And we are able to almost reduce transit time by a factor of 2, which is quite interesting in this particular case. So this is a visualization, and you'll see why I'm showing you that, where you see the rail, you see the buses, and then you see the shuttle. You mostly see the shuttles because there are many of them. But you can see how they are acting as feeders to the bus lines and to the rail lines. Now, so how do we build trust? We build trust because we build this very sophisticated simulation. In the visualization that I've shown you, we know exactly how many people are in every bus, every train, every shuttle. We know where they are going. It's a very high fidelity simulation. And the models are also very high fidelity. But still, in general, this is not sufficient to build trust with agencies. One of the things that they will tell you is that you are building a better system. How do you know what's going to be the exact demand? Because more people can adopt the system. So when you do something like that, what you need to do is to build these bilevel optimization models. So you are basically building, the designer of the system is going to propose a design, but then everyone is going to look at the design and say, hey, do we adopt the system on that? So it becomes this kind of a game between the transit agency and then the riders. And so these problems become much more challenging to solve again. And this is an example of 2 cities in Michigan where you can see various populations. The different colors are showing you the revenue, the class of income of various people there. And once again, what was done there is basically building this bilevel model. And one of the things that you can see is, this is the existing system transit time. This is a new system for the existing riders, but you see also new riders adopting the system. And in those particular cases, you can see that the time that they take is almost the same as the direct time. And you can also see that these systems are almost profitable. So this is without any subsidies, they are essentially breaking even. Now, once again, people are going to say, yeah, you have a nice simulation, but this is not really what is happening in practice. So the last step, if you really want to convince people and build trust, is building pilots in the field. And so we did that in Michigan, actually. So this is one of the shuttles that we have. We built all the mobility apps, all the high performance servers to actually serve these systems. And this is one of the animation, well, actually one of the recording of my screen when I was monitoring what was happening in the screen. So every evening when the system was running, I was watching this. This is more interesting than CNN. So you can see all the drivers doing very interesting things. So you'll see Kelsey, this is the driver which is there, and you're going to see that she's going to do something very interesting. But we had to see what the drivers were doing in practice, and they were doing they were not necessarily following the instructions on a mobility app. They were also driving much slower than we expected. They don't drive at the speed limit. So you see Kelsey, she has to pick up this particular rider, but she doesn't know she can go right. So she will do a much longer road and go through this parking lot that you don't see on this map. But the drivers are not we had to spend a lot of time with the drivers such that they follow instructions. And they actually do the right thing. So you're going to see Kelsey now going through this parking lot. It's actually very interesting. And you have to take those things into account and refine the system constantly. So that's what I'm telling you. You learn a lot by doing these pilots, and this is a very important step. It's very time consuming, but at the end of the day, you learn a lot about what it takes to actually build the systems in practice. So this is another thing that we learned. This is a very interesting anecdote. So this is a dorm in the university campus. And so we had all these students moving there to this particular place, and I was wondering what was there. And at some point we found out that that was a beer place. This is a Friday night. So a lot of people were using the transit system to actually go to the beer place and come back. So that's what I wanted to tell you, and I hope that I addressed some of the questions that Michela asked us. Thank you very much.
Okay, so thank you very much, guys. And Pascal, I mean, your talks at 5 o'clock in the morning are way more lively than mine at 10 o'clock in the morning. So thank you so much. And also, I mean, I'm sorry for the time zone.
It's Italian coffee, Michela.
So, I mean, I think that now it's time for the audience to set up some questions so that we can ask directly our panelists. I have a starting one. So while waiting that people are asking their questions. So Carla and Barry, you mentioned some ethical constraints and decisions that are aligned with human values and so on. So first of all, I would like to have, for example, from Carla's one example. So what are the decisions that should be aligned with human values in her application, for example? And the second thing that I would like to understand is really how, I mean, the ethical guidelines sometimes seem very abstract, very high level, and not very close to reality. So how can we really implement these ethical guidelines in AI systems? So this is, I think, an important question when we have both industrial applications and also when we try to solve social challenges.
Maybe Carla wants to go on the first part.
Oh, go ahead, Barry.
Yeah, sure. Okay, so I suppose just on the second part of your question, the sort of abstract nature of these things, yes, that is true. Many of these things can appear to be very abstract. I suppose, in terms of bringing them into your daily life, in some sense, some of these things are methodological. In terms of just sitting back and thinking about the impacts of the work that you're doing. What issues arise? Sometimes ethical issues and alignment problems can actually be formulated as constraints and essentially just represent good AI practice. So there are lots of people who are beginning to formulate the technical concerns related to ethics as hard constraints in their systems. And so some of these things don't have to be very abstract at all. So, there have been papers recently from IBM and others on how to formulate value alignment problems. Stuart Russell, in his presentation, in his keynote address at IJCAI last year in February, the last physical conference I managed to get to. At the end of his talk, he gave some very nice examples of how ethical issues between multiple agents basically are just constraints that can be formulated directly and included in the problem. So some are so I suppose in short, some are methodological issues, some are things you can actually build in and express in your systems. So there's a wide variety of ways in which you can deal with these things. Back to Carla, maybe.
Yeah. So I think you raise good points, and often, for example, we actually frame this question in terms of often there are a decision will have multiple impacts, and the challenges are how, in fact, there are even the trolley problem. If a car has, should the car kill one person, an old person, or young people? I mean, if it has to make a decision. So these are indeed challenging questions. But we also, in the example that I showed, I really think several problems in the end equate to considering the different impacts that our decisions have. And in terms of the Amazon, this proliferation of dams, it's obvious that you would, and in general, all the planning is focused on increasing energy output, but the consequences are tremendous. Really, in terms of the populations that, frankly, in the Amazon, it is not the case that a lot of populations are disrupted. But for example, in China, the Mekong River, that is really quite something. But issues like fragmenting the river, those populations really live on fish, and that really is devastating for the fish. So that is one way how we have try to capture the problem, and we do exactly the Pareto frontier, because we feel that it's not up to us to assign a weight to a particular criterion. Typically, we just give weights, and then we have a single objective function, which is easier. However, it's not up to us, and to come up with that has been a bit of our position, and so I feel that it's important, related to your question, indeed, to actually show policymakers, this range of possibilities, but the range of implications across, different dimensions and criteria. But, there are many other aspects. Maybe Pascal, I think Pascal used, in fact, I thought, the way he framed the question in terms of, in fact, a lot of the mechanism design, they require optimality for them to actually work. And I thought that point was quite interesting that Pascal raised, but maybe he wants to add some other comments.
No, so I agree with what Carla is saying. I think our role as an engineer or computer scientist is to actually help policymakers to make the right decisions. We have also a lot to learn from other communities. For instance, obviously in energy, you have all these market clearing algorithms, as Carla just mentioned, and they have been chosen just to be fair and to make sure that there is competition and the market is imposing some degrees of fairness. When you look at what is happening in the transportation industry, the policymakers have a certain number of rules, and in the United States at least, that's the part that I know the best. You have regulation like Title VI, which are making sure that different population segments have the same quality of service. So these are all kinds of things that are happening in communities and that we should be aware of. And I think, as Barry has said, we have to incorporate them as as requirements inside the systems that we are designing. Now, it's not always easy to do this because it complicates everything, because it's only when you design the system that you can actually evaluate how well it serves the various communities. So I think this is a very rich area and very difficult area. We have also a lot to learn from different communities, but I think we have also a lot to offer. But we can think of this in terms of policy making and informing policy makers. I think that's one of the right way to phrase this.
Yeah.
Okay, thank you very much. So we have a question from the audience from Lawrence Granrath. So I don't know if you can use your microphone, Lawrence, or if you only have to write it somewhere on the chat.
You will have to write it.
Okay, so Lawrence, could you write your question on the question and answer panel so that I can read it for you and our panelists can reply? Because I mean, yeah, I think that the people that are participating cannot see the talk. Yeah. So he has a hand.
Of course, that could just be a mistake.
Okay, so waiting for the question of Lawrence. So I have another curiosity for Pascal. So you were saying that basically it's important to have, for trust, it's important to have realistic models that basically show the policymakers to, I mean, that we are using a model of the system that anyway is not, I mean, the approximation is very fine-tuned. But so do you think that you can extract some I mean accurate model from the pilots directly? So do you use the data that come from the on-field pilots for feeding like simulators or models to become more realistic, or how do you proceed?
Yeah, most of the time the pilots are informed by real data, right? So you start always with the data which is existing, because that's what you have, you know, who is using the system, how they are using it. But then you start making assumption. I was telling you that, you know, when we designed the first system in Michigan, we basically assumed that the drivers would at least ride at the speed limit. And this was completely wrong. They are actually driving much slower because they are trying to be really safe. And so what you do is that essentially the transportation times have to be adjusted. You can obviously adjust them dynamically using techniques from reinforcement learning and things like this, if you can, when you operate the system. But we were very surprised because initially it was configured wrongly. We were assuming that the drivers were much faster than they actually were. So you have to, and then you have to understand how people are going to adopt the system. So you learn a lot from both the pilots and then the simulations afterwards. Absolutely. I think there is a very healthy cycle between actually doing a pilot and then reinforming the simulations based on the pilot or the system operating the entire transit operations. So yeah, absolutely. I think this loop is very healthy, very, very healthy.
And this also involving, policymakers, will show them that, the models that you are working on are not far from reality, which is, I think, at the basis of trust.
They were very surprised because, you know, the people in the transit agencies were saying, hey, I have a direct bus from this point to that one. But, you know, the students are using actually the on-demand component. Why do they do that? And they don't realize that young people are very used to have their phones and order a ride. It's much nicer than going to a bus stop and waiting for a bus. And so I think people are surprised, and it's only when they see the operations that they actually start understanding it and trusting it. So it's actually, I think we learn a lot when we actually do these things and interact with policymakers and understand where they are coming from.
Mm-hmm. Yeah.
Yeah, we had the same problem when we used a mobility simulator. It was a micro simulator, and basically, in my city, I was always finding a congestion in a place that could never be realized on that simulator. So basically, the two models were the model was not really realistic. So every decision that you take on top of that is completely useless. So I don't know, because I don't see the questions from Lawrence on the question and answer chat. So he has his hand raised, but I don't see the question. So I think that you have to write it down on the chat, Lawrence, because otherwise we cannot hear you. I'm sorry about that. Okay, so it's a pity that we cannot have.
Yeah, I don't see any questions.
Okay.
The question.
All right.
Yeah, that's not from Lawrence. Anyway, how will the transportation community get affected in the renewable world? Who wants to say something here?
Can you repeat the question?
How will the transportation community get affected in the renewable world? I think that you also can see that on the chat, question and answer in chat.
Yeah, I don't see it. That's interesting. Okay. Yeah. Oh, yeah. I seen it. Oh, yeah. I see.
Sorry,
I think the transportation industry is going to be. I mean, so to give you a sense, I don't know in Europe and in Asia, but in the United States, the greenhouse gas emission from transportation is about 30%. And out of this 30%, I think 60% is coming from small cars and trucks. So I think there is a tremendous opportunity to reduce greenhouse gas emission by electrifying the entire transportation community. That means not only electric cars, but that also means electrifying the public transit systems and so on. And I think this is one of the nicest way to actually reduce greenhouse gas emission. It's very natural to do so. I was mentioning that in the case of transit, we own the entire fleet, we control it. So charging is not an issue. You don't have, range anxiety. I think this is going to also put some stress on the energy system. But this is also an interesting challenge for the scientific community. How do you deal with the charging and of electrical vehicles? And once again, I think in the United States, you have seen maybe some of the new directive from FERC, which is allowing demand response to be part of the market, which is also one of the ways that you can deal with this increase in electrification in a nice fashion. So I think there will be a lot of development in the intersection of electricity and transportation in the next couple of years.
Yeah, if I could just add, I suppose one thing that the last few comments have highlighted is the importance of getting access to the real data, getting access to actually being able to work on the real problem. And I suppose this comes down to we have to, as a sort of community of researchers, we have to think differently about what impact means. It's not necessarily the next IJCAI paper, although that is very impactful. It's how, can you really affect the problem? And that's actually very challenging. I think one of the things that, if I may say so, that Carla and Pascal have done very, very well is that they really do get the real data and they work on the real problem. They don't work on abstractions of those problems. And I think that's really, really important. I think particularly, in transport, as you say, Michela, if you use some simulator, nice and all as it is and sophisticated as it is, you lose the sort of the richness of I suppose, the dirtiness of the real problem,
Yeah, I need to drive in Italy. That's crazy, of course.
Yeah. How do you simulate that?
Okay, so I think that it's time to close the panel. So let me really thank you all, guys. It was nice to see you, even if virtually. I would love to see you in presence very soon. Thank you for your contribution. Thank you to all people that have participated. I'm sorry that maybe not all of you can have the opportunity to give to ask questions, because I mean, I don't know, there are some hands that are there, but no questions on the chat. So I don't know if you had problems in accessing it. So let me again thank Carla, Pascal, and Barry for their fantastic contribution. This is also been organized with Sabine. So thank you also to Sabine. So guys, have a nice day or night, depending on the time zone. Thank you so much, and see you soon. Bye-bye.
Thank you. Bye-bye.
And Pascal.
Thank you, Michela, for organizing this. Thank you very much.
Everybody.
Absolutely.